Japanese scientists have been working on a project for more than 20 years. They have selected a place inside a mountain and allocated a budget of $600 million for it. So, what are they planning to do inside the mountain? They are building a device called Hyper-Kamiokande. It's a structure 80 meters tall and 70 meters wide. This massive structure is being built inside a mountain. If you enter this structure, it looks like this, but this is just a smaller version. The actual one is a much larger cylinder, with cameras and sensors installed all around it. Now, what is this thing, and why are they investing so much money and time in it? Before we enter Hyper-Kamiokande, let's gather some background information. We somewhat understand our universe. The entire universe is made up of various atoms, and these atoms are made up of smaller particles. Particles like quarks, bosons, and neutrinos, the tiniest particle of an atom. Neutrinos are so small that they can pass through anything. Billions of neutrinos pass through our bodies every second, entering and exiting without us noticing. They easily pass through skin pores or any other barrier without leaving any trace. That's why collecting information about neutrinos is extremely difficult. Something this tiny that can pass through anything. How can we capture it and observe it? Currently, the only way to observe neutrinos is by smashing two atoms together at speeds close to the speed of light, as they do in the CERN laboratories in Switzerland. Now, let's see what the Japanese are building and what their main goal is. Near the small city of Kamioka, there's a mountain called Nijugo. All these facilities will be installed inside this mountain. But what does inside the mountain mean? Is it hollow? No, it's not. They have to excavate the mountain and carve out a large space from its core. You might ask, couldn't they find a better place? Why inside a mountain? Such a laboratory needs to be located where there's minimal radiation interference. That's why they chose a remote area inside a mountain, where nothing can reach it except neutrinos. The Hyper-Kamiokande project was initiated by the University of Tokyo. Over the years, 22 countries joined this project. The goal of Japan and the other 21 countries is to build the largest neutrino detection facility. As mentioned before, a smaller version of this facility already exists, called Super-Kamiokande, located near Hyper-Kamiokande. Super-Kamiokande was built underground in 1996. To make it effective, they went 1,000 meters below ground. But later, they realized that this center needed to be larger to achieve their goals. An experience showed that going that deep underground made the work much more challenging. So this time, they decided to build it inside a mountain. A place far from radiation, but not at the Earth's core. It may seem strange since neutrinos can easily pass through entire planets without hitting a single atom. But still, building it inside a mountain is solely to protect it from various types of radiation. Experts say the mountain excavation will be completed this year. However, this excavation, though it has taken years, is the easy part. Afterward, they need to coat the walls of this cavity with 2 layers of concrete and waterproof it with special layers. This ensures that when it's filled with water, no water leaks out. Believe it or not, when this cavity is completed and filled with water, it will become the world's largest water tank, holding 260 million liters of water. Filling it will take more than 6 months, even with high-power pumps. Now, why fill it with water when cameras and sensors will be installed? We'll get to that. The water they plan to pour into this giant tank must be extremely clean, so pure that it contains nothing but water. This is called ultra-pure water. Now we come to why they are filling it with water. Because water is the best medium for observing neutrinos. When a neutrino passes through this water, most of the time, nothing happens. It passes through undetected, but occasionally, as it moves through, it may collide with an electron. And as you know, an electron is a particle of an atom. When a neutrino collides with an electron, a light is produced. But it's a light that neither you nor I can see. Not even with the naked eye or advanced equipment. However, thousands of cameras and sensors installed around this tank are ready to capture this moment. This simple collision is the reason they're spending over $600 million and waiting more than 20 years to build this facility. The cameras to be installed in this water tank are so sensitive that if a small bulb were lit on the moon, these cameras could detect it. That's how sensitive they are. And without such sensitivity, it would be impossible because neutrinos are incredibly hard to observe. Even when they collide with an electron and produce light, we still can't see it. So, how will these cameras withstand the weight of the water? The water, weighing 260,000 tons, will press against these cameras. Special coatings have been designed for these cameras to endure this weight without damage. Believe it or not, this project has been in planning since 1999. First, the maps and designs were prepared. It took 22 years to finalize these designs and maps. By 2021, they began excavating the mountain to implement the plan inside. You might think they're working slowly, but they're actually moving quite fast. Because a project like this is no joke. The University of Tokyo announced that the facility would be ready by 2027. Now, what will happen then? When a neutrino collides with an electron in the water, producing a spark, what's the point? What information will it provide us? For billions of years, neutrinos have been passing through everything. They're still passing through us without causing harm. Why are we trying to capture them? What benefit does it have for humanity? You should know that particle physics, which includes the study of neutrinos, is crucial for human progress. Take MRI machines, for example, machines that don't use X-rays or radiation. How do they capture images? Through particles. It was particle physics that enabled you to see our images today. Tim Berners-Lee, a particle physicist, along with other physicists at CERN in Switzerland, invented the World Wide Web, or the global internet we use today. They didn't set out to invent the internet, but in their pursuit of particle physics, they reached a point where they realized it could be done. Similarly, the scientists at the University of Tokyo and the 22 countries investing in this project believe that by studying neutrinos, they can achieve incredible breakthroughs, much like the invention of the internet, which changed the world. Perhaps if Japan were allowed to invest in military weapons like tanks and missiles, they wouldn't focus on particle physics. But this is a positive thing that a country chooses to explore such paths. Instead of building weapons of mass destruction,